Swayam Prabha. Digital India. Educated India.
Hello everyone, I welcome you all to the lecture 13 of this course, Construction Methods and Equipment Management. So in this series of lectures on earth moving equipment, today we are going to discuss about the front end loaders. So in the last lecture, we have discussed about the scraper, like the types of scraper, application, the operation of scraper, and how to estimate the productivity of scraper we have discussed. So let us see what is the outline of today's presentation. In today's presentation, we are going to discuss about the types of front end loaders, what are all the different possible attachments for the front end loaders, and what are the applications, and how to do the bucket rating for the front end loader, and the significance of bucket fill factor, and how to check the payload from stability perspective, and how to define the production cycle of the loader, and what are all the components of production cycle, and illustrations on how to estimate the productivity of the front end loader. So these are the components which we are going to discuss today. So as the name indicates, front end loader means it is basically a tractor with a bucket at a front end. Okay, a tractor provided with the front end bucket is called the front end loader. So you might have seen this the front end loader very commonly in many project sites. So the basic difference between this machine and the earlier machines which we have discussed, like bulldozer and the scraper, is that this machine has a mechanism which facilitates it to lift the material and load it into the truck. So you have a boom kind of thing which allows it to lift the material. Okay, you can lift the bucket and load it into the truck. So this is not possible with the bulldozer and the scraper, where you cannot lift the material and load it into the truck. So that is one advantage of this machine over the earlier machines what we discussed. So this is basically a kind of excavator which is good in excavating at or above the ground level. Okay, so and in addition to that, it can also transport the material to certain distance. That is one advantage of this loader. Okay, so it can excavate as well as transport the material. So that is the advantage of the loader. But when you compare this machine with the other excavators, like fixed position excavators, which we are going to discuss in the upcoming lecture, so like your front shovel, the shovels. So when you compare this machine with this front shovel, you can see that this fixed position, the front shovel is a fixed position excavator which is very good in excavation, but it cannot transport the material to a particular distance. It has very poor mobility. So it has very poor mobility when compared to loader, front end loader. So a front end loader can give you an economic haul distance of, say, if it is going to be wheel mounted, you can even go up to 200 meter. So if it is going to be crawler mounted, it will be less than 100 meter. But if you look into these front shovels, the haul distance will be maybe less than 20 meters. So this is not designed for transporting the material. Okay, this front shovel or fixed position excavators which can just stay at one place. Okay, and you can just swing the boom from the loading to the dumping position. Okay, so but the advantage of the loader is it can excavate the material as well as it can move it to certain haul distance. Say, depending upon the mounting, you can go up to 200 meter for wheel loader or less than 100 meter for crawler loader. So that advantage you can have with the front end loaders when compared to other excavators like front shovels. So we have just compared the front shovel and the front end loader. But basically, if discussed from the cost perspective, you can see that the loaders are cheaper when compared to the front shovels. There is another advantage. So very commonly you can see this front end loader in the batching plants. Okay, your the ready mix concrete factories or asphalt batching plants, you can see this machine very commonly. Okay, so like in the batching plants, you can see that the aggregates will be brought by the truck from the aggregate production plant, and the truck will dump the aggregate at the batching plant. So from the dumped stockpile, okay, this material, the aggregates will be carried by the loader, and loader will to feed the material into the storage bins. Okay, so into the aggregate storage bins. Aggregate storage bins. There will be some storage bins for aggregates at the RMC batching plant. The charging of storage bins, charging of aggregate storage bins will be done with the help of loader. So, the loader will carry the material and then load it into the storage bins. So, that is another application. And another thing is, it is also used in aggregate crushing plants. In crushing plants, you can see that the loader can dig the quarried rock, okay, the blasted rock or the short rock. Okay. So, this loader can dig it, okay, load it, and then it can transport it to a certain distance and then take it to the aggregate crusher, okay, and feed it into the hopper of the aggregate crusher. So, that way it can help. See, in certain cases where the haul distance, the transporting distance is not favorable for the shovels, okay, your front shovel, when it is not favorable for the shovel, in that case you can go for the loader, which is both good in excavation as well as it can transport it to the required distance. So, in that case your loader will become advantageous when compared to the shovel. So, these are the applications of the loader. So, let me just summarize. So, basically the loader is good in excavating at or above the wheel or track level, and also it is used to transport the material to certain economic haul distance. We have discussed about the haul distance. It varies depending upon the mounting of the machine, and it is designed for excavating soft to medium hard material. With soft to medium hard material you can get a good productivity, but for a very hard material you can do it, but the productivity will be slightly lesser. And very commonly you can see in the quarries to load the blasted material into the truck. Okay, that is one application. And as I mentioned just now, it can load the hoppers and bins in the asphalt and the concrete plants, to load the aggregate bins in the asphalt and the concrete plants, and also to feed the aggregate crusher, use the loader. So, these are the different applications of the loader. Now, let us see what are all the types of loaders. Okay, you can classify the loader based upon the capacity of the bucket, or based upon the mounting, or based upon the frame. So, based upon the capacity of bucket, you have a huge range of the capacity, say starting from less than 1 meter cube, say 0.2 meter cube, to as big as say 15 meter cube bucket is also available. So, depending upon your requirement, you can go for the corresponding bucket, the size accordingly. And based upon the mounting, as we discussed for the earlier machines also, it can be either a crawler mounted or track mounted, or it can be a wheel mounted. And based on the frame, it can be a rigid frame or articulate type frame. We are going to discuss all these things one by one in the upcoming slides. So, first let us compare the wheel loader versus the track loader. Obviously, as you know, wheel loader will give you high mobility. So, wherever you need higher speed and greater haul distance, you can go for the wheel loader. With wheel loader, I can go for an economic haul distance of up to 200 meter. So, excellent job mobility and greater speed. But the main advantage of track loader is it has all terrain capability. That means it is suitable for very poor underfoot conditions also. Okay, it can climb steeper grades for a very rocky terrain or clayey terrain. Very poor underfoot conditions also, it can give you better productivity with the track loader. So, another important thing you should note that, so obviously the track loader will give you a better traction. So, because of the tractive effort generated and the breakout force generated will be more in the case of track loader. Okay. So, that is why for very tough job conditions, particularly for the quarries, for handling the rock, it is preferable to go for the track loader, which can generate more amount of tractive effort. And you can see that the loaders, particularly since it is carrying the material and travelling for a particular haul distance, we are very much concerned about the stability of the loader. We should take care that the machine should not tip, it should not tip forward. Okay. So, for that case, we have to see that machine stability should be taken care. So, basically even in the track loaders, you can see that the tracks will be generally longer and wider, so that you can increase the stability. Okay, particularly for the loaders, the tracks will be longer and wider. So, from the safety perspective, and also most of the crawler loaders, you can see that the engine will be at the rear end. Okay, because the weight of the engine will also act like a counterweight to the load in the bucket. Okay, so for that purpose they may have engine at the rear end. So, if you compare the cost, obviously your track loaders are going to be costlier. Okay, the ownership cost is going to be costlier for your track loader. But when you estimate the cost, work out the economics throughout the life of the equipment, you can see that the replacement cost of the tires, the wear and tear of the tires will be more for the wheel loaders. Okay, so that will make the wheel loaders expensive. Okay, when you consider the tire cost in the operating life of the machine. So we have to work out the economics and select accordingly. Okay, then based upon the type of frame, you can either go for a rigid frame or you can go for a articulated frame. Okay, so what is this articulated frame? Basically, there is a pivot joint between the front axle and the rear axle. There will be a pivot joint. The machine is hinged between the front and the rear axle. So this joint will facilitate better turning or maneuvering. So like you will have a better turning ability for this machine. So even in a very confined area, it is possible to work with this machine. Say for example, you are working on the side of the road, some trenching work is being done on one side of the road. In that case, the turning will be very easier to work in the narrow spaces with the help of articulated wheel loader when compared to rigid frame loader, because this machine will have a better turning ability due to the joint, the pivot joint between the front part and the rear part. So you can have an articulation of say 40 degree in the horizontal plane, either to the left or to the right. So you can see this in the picture. So they are basically hinged between the front and the rear axle to provide greater maneuverability. It allows an angle of up to 40 degree in the horizontal plane, either to the left or to the right. So this machine can easily work in small turning circle. Of course, it is going to be costlier than the rigid frame, but the cost can be justified whenever you want the machine to work in a very confined area or spaces with space restriction. Now let us see what are all the possible loader attachments. There are different types of attachments possible. Okay, depending upon the attachment, your application of the loader will vary. So the first one is a general purpose bucket, which we commonly use it for handling the earth. So as we discussed earlier, for the bulldozer, even for this bucket, at the bucket proper, you will have the cutting edge. So generally, the cutting edge gets worn out fast due to the wear and tear. So this cutting edge will be just bolted on. It will be just bolted on to the bucket proper. So you need not replace the bucket frequently. So only the cutting edge we need to replace it frequently depending upon your usage. So the cutting edge is just bolted on. So in general purpose bucket, there will be just one plain cutting edge. You may not even have this teeth. Okay, these are called as a teeth. Okay, they are the V-shaped cutting edge with the bucket teeth. So basically, in the general purpose bucket, you can see the cutting edge will be plain. You need not have the V-shaped cutting edge or the teeth for handling the rock. But if you are going to handle the rock, you have to go for a special bucket like this, rock bucket with this kind of teeth, with V-shaped cutting edge. Okay, the teeth has V-shaped cutting edge with which it can easily loosen the rock and it can easily fill the bucket with the rock. So this type of cutting edge will help you to loosen the rock. So this is usually used for the rock bucket. And there is something called a side dump bucket. So generally, instead of dumping in the front end, if I wanted to dump in the side end, either to the left side or to the right side, then I can go for this side dump bucket attachment. So this will be more convenient if you are going to work in the confined areas. Like say for example, as I told you, when I am doing some trenching work on the side of a road. In that case, if you want to dump in the side end, with the side dump attachment, it will be very easier to dump instead of turning the entire machine. Then multi-purpose bucket. This is something called as 4-in-1 bucket, where the same bucket can be used for different applications. You can either use it as a bulldozer blade, or you can use it as a scraper, or you can use it as a loader, or you can use it as a clamshell. Okay, we will see what is it in the upcoming slide. And another attachment called forklift, for lifting the objects, for lifting the precast elements, I can use this forklift. Then plow blades attachment, particularly in the snowy areas, for clearing the snow. Then light material bucket. Basically, when you are going to handle a material with the lower density, you can go for bigger size bucket. But if you are handling a material, denser material, then you have to go for a smaller size bucket. This is mainly from the safety perspective or the stability of the machine perspective. Okay, this is the picture of the rock bucket which shows the V-shaped cutting edge. You can see the V-shaped cutting edge. With this, even this bucket teeth is bolted on. You can easily replace the bucket teeth when it gets worn out. So, this is particularly used for handling the rocks. When you are working with the loader in the quarries to handle the blasted rock or the short rock, then you have to go for this rock bucket, which can easily loosen the rock and load the bucket. This is the side dump attachment. This is just a schematic picture of the side dump attachment, which you can use it in confined areas where you want to do the dumping on one side. I do not want to do the dumping in the front end, but I wanted to do the dumping either to the left side or to the right side. Then I can go for this kind of side dump attachment. Forklift. So, you can remove the bucket and attach the forklift to the tractor, so that you can use the loader for carrying the elements. Say for example, you want to carry some objects, precast elements, you can use the forklift attachment. Then the one is multi-purpose 4-in-1 bucket. As I told you, all these 4 functions are possible with the same attachment. You can either use that bucket as a dosing blade, or you can use it as a normal loader, or you can use it as a scraper, or you can use it as a clamshell. So, clamshell is something which is used for vertical digging, okay, for digging vertically, for deeper digging, we can go for this clamshell. So, the same bucket I can use for any of these functions. That is why it is called as multi-purpose bucket. Now, let us see about the bucket ratings. See, the manufacturer provide you the information on what is the heaped capacity of the bucket. So, this bucket rating is done by the manufacturer in a standard manner with a particular material. Say they heap the material at a standard angle of repose, say is 2:1, and then rate the bucket based on that. Okay. So, that bucket rating, we are going to use it for the estimation of the productivity of the loader. Okay. So, but in your actual project site, the material which you are going to handle, okay, that may be different from the material which was used for the rating of the bucket by the manufacturer. Okay. So, you know that different material will have different filling ability. Say for example, when you are going to handle sand, okay, sand has a particular filling ability. Okay. If you compare sand and if you compare the coarse aggregate, if you compare bigger size coarse aggregate, okay, sand has better filling ability when compared to the coarse aggregate. Similarly, when I compare the aggregate versus the blasted rock or the short rock, obviously aggregate will have the better filling ability. So, the filling ability of the material into the bucket will vary from material to material. So, that is why according to the material which you are going to handle at your project site, you have to apply the correction factor to the rated bucket volume by the manufacturer. Okay. So, the manufacturer would have rated the bucket. So, that is the rated bucket volume, heaped bucket volume. This data I can get it from the manufacturer for different bucket capacities, for different bucket sizes I can get it from the manufacturer. This value I have to adjust according to my material type which I am going to handle at my project site. So, I have to multiply this rated bucket volume given by the manufacturer with the bucket fill factor, which depends upon the material type. So, this value also I can get it from the literature. For different material, depending upon the size of the material, the filling ability will vary. So, the bucket fill factor will also vary. So, it not only depends upon the material type, it also depends upon the mounting of your machine. So, your machine may be either wheel mounted or it can be either track mounted. So, generally as you know, the track mounted machine will give you better tractive effort. It will be able to generate more amount of force, breakout force. So, say it can easily loosen the material and it can easily fill the material into the bucket. So, the filling ability will be more when we go for the track mounted machine when compared to the wheel mounted machine. Okay. So, that is why the type of the mounting will also affect the bucket fill factor. So, this bucket fill factor helps to make the best estimate of the actual bucket volume. So, the fill factor correction for the loader bucket adjusts the heap capacity given by the manufacturer based on the material type and the type of your mounting of your machine. So, the material type which you are going to handle, the material which you are going to handle at your project and the type of mounting of your machine, okay, according to that your fill factor will vary. With that fill factor you adjust the actual the bucket volume rated by the manufacturer. As the traction depends upon the mounting, the bucket fill factor also varies for the wheel and the track mounted loaders. So, the track mounted loaders will give you better traction. So, it can easily loosen the material and it can easily fill the material into the bucket. So, the bucket fill factor will be better, will be different for the track mounted loader and the wheel mounted loader. Now, another important thing which we need to check, particularly for the front end loaders, is we need to check for the payload weight from the stability point of view. So, you know that your front end loader is going to carry the material in the bucket in the front end and it has to travel for some economic haul distance. Okay. So, unlike the other excavators which I discussed earlier, say your front shovels, say if you compare this machine with your front shovel, which is also an excavator machine. So, that is not going to travel from loading to dumping position. They are fixed position machines. They are fixed position machines. But this loader will be traveling. Loader can move the material from the loading to the dumping point. That is why in this machine we are more concerned about the stability. There are more chances for the tipping of the loader machine if we overload the bucket. Okay. So, that is why we have to check for the payload weight. Okay. So, these machines are basically traveling with fully loaded bucket and the bucket will be in the raised position in the front of the tractor and it will be traveling. So, that is why there are more chances for instability. So, we have to carefully balance, we have to match the size of the bucket and the size of the tractor. For a very small tractor you should not put a bigger bucket. So, that will affect the stability of your machine. Safety against tipping forward is taken care by checking the static tipping load. Okay. So, how the static tipping load is determined, we are going to discuss in the next slide. So, we have to check whether the payload weight, the actual load in the bucket is within the static tipping load prescribed by the manufacturer. What is this tipping load? See, just like you imagine your seesaw, like if you are going to put more material into this bucket, as you keep on adding material into the bucket. So, at one point of time you can see that if the bucket is overloaded, the rear wheel will be lifted off the ground. So, that is what is called as the tipping of the bucket. So, your rear wheel will be lifted off the ground as you put more and more material into the bucket. So, this static tipping load is determined by the manufacturer under standard conditions. So, how do they do this test? So, basically what they do is they carry out the test by putting material into this bucket. They look for that particular point of time at which the rear wheel will be lifted off the ground. That particular load is called as the tipping load. That particular load is called as the tipping load. So, how much load we need to add into the bucket which will cause the lifting of the rear wheel off the ground, that is called as a tipping load. Okay. So, this test will be done by the manufacturer and they do this test in static condition to avoid the variability, and the machine will be in fully turned condition or articulated condition. That is going to be highly risky. So, the machine will be in fully turned condition when they do the test. I hope you understand the difference between straight and fully turned. Okay. So, when it is fully turned, it is going to be more risky. So, they carry out the test from in the fully turned condition. So, basically full turn static tipping load is the loaded weight which will lift the rear wheel off the ground with the machine in static condition and fully articulated state. So, this is how they determine the full turn static tipping load. This value you can get it from the equipment handbook. The manufacturer will provide you for different bucket capacities what is the full turn static tipping load of the machine. Okay. That value I can get it, and you have to check whether the operating load of your machine, that is the load in the bucket, should be well within the full turn static tipping load prescribed by the manufacturer for that particular machine. Okay. So, the load in the bucket should be well within that. Okay, so we should go for a very high factor of safety. The factor of safety depends upon the mounting of the machine. Okay, so the guidelines are available in the literature. Say if it is going to be wheel loader, the operating load in the bucket is limited to 50% of the rated full turn static tipping load defined by the manufacturer. Okay. Similarly, if it is going to be track loader, the operating load is limited to 35% of the static tipping load. Okay. So, you have to ensure, okay, that the load which you are going to put in the bucket of the loader should be well within the full turn static tipping load. So, the factor of safety will depend upon the mounting of your machine. So, as I told you, the specifications I can get it from the manufacturer. Now, let us define what is the production cycle of the loader. Okay. So, what are all the components of the production cycle? As we discussed earlier, the same way we can split the production cycle time into two components. One is fixed time, other one is your variable time. Okay. The fixed time does not depend upon the haul distance. Say the time needed for the loading, dumping, turning, your maneuvering the changing gears, and also for spotting your truck. Okay. So, the loader has to spot the truck, okay, then only you can dump the material. Okay. If it is not able to spot the truck is not readily available, even that will increase your cycle time. So, the fixed time is reasonably constant, the time required to load the bucket, shift the gears, to turn and to dump the load. The maneuvering time and the time for spotting the hauler also comes under the fixed time. So, obviously, the variable time will depend upon your haul distance and the speed of the machine. The speed of the machine, you can get it from the performance chart as we discussed earlier, or you can get it directly from the manufacturer. Manufacturer may provide you the possible speed for different capacities of the loader or different capacities of the bucket. What is the maximum possible speed? The first gear, second gear, third gear, all this information are provided by the manufacturer. So, based upon that also you can estimate your variable time. The variable time includes the travel time required to travel from loading to the dumping position and the time required to return to the loading position. So, obviously, it depends upon the travel speed and the distance travelled. So, this picture shows the plan for the ideal loader setup. Okay. So, basically, though the loader is able to transport the material for certain haul distance, okay, it is always preferable to place the truck as close to the loader as possible, particularly for the track mounted loader for which the economic haul distance is less than 100 meter. It is always preferable to have the truck as close as possible, so that you can improve the productivity of your loader. So, that is what we call it as ideal loader setup. So, you can see the production cycle here. Okay, this is your truck and this is the bank which the loader is excavating. So, and this shows the path of the loader. So, the loader is first moving to the bank, excavating the material, then it will take the apply the reverse gear and move in the reverse direction. Now, it will move forward to the truck and dump the material into the truck. Okay, again take the reverse gear, move in the reverse direction and get ready for the next cycle. Okay, this is how the production cycle gets repeated. This is called the ideal plan. This is because the travel time is minimum here. Particularly the crawler loaders are also not designed for a very high haul distance. So, it is preferable to minimize the travel time of the loader, but everything depends upon your actual project condition and the site requirement. And another important thing you have to note that is when the travel time is minimum. So, when the travel time is minimum, okay, say if the truck is placed very close to the loader, say less than 5 meters or approximately 15 feet. So, in that case the travel time is going to be, travel distance is negligible. I can say the travel distance is negligible, okay, and the travel time is minimum. So, in that case directly I can take the fixed cycle time for the loader from the manufacturer, because for distances less than 5 meters there is not much variation in the fixed cycle time. So, that is why you can take it directly from the manufacturer, the fixed cycle time based upon the bucket capacity of your loader. Okay. That itself will give you the total cycle time of the loader when the travel distance is negligible. That means when the truck is placed very close to the loader, say within 5 meters. Okay. But if the travel distance is not negligible, so in that case you have to estimate your variable time. Okay. So, how to estimate the variable time? There are some guidelines given in the literature, you can follow that guidelines. Say obviously you know that when the machine is travelling with the load during the onward journey, the speed is going to be lesser when compared to the return journey where the bucket is going to be empty. And also the speed possible depends upon the haul distance. If the haul distance is going to be lesser, in that case your the travel speed is going to be lesser. For distances less than say 30 meter, your average travel speed with the loaded bucket for the wheel loader should be 80% of the maximum speed in the low gear. So, this is a guideline available in the literature which we can use it in the estimation of the speed when you estimate the productivity. So, for the onward journey with the load for the wheel loader, you should take the travel speed as 80% of the maximum speed in the low gear as given by the manufacturer. So, as I told you, for different bucket capacities, what is the maximum speed possible? The first gear, second gear, third gear and the top gear is given by the manufacturer. Okay. So, you can use it and find this. And similarly, for the return journey, when the bucket is empty, the return speed should be about 60% of the maximum in the second gear. So, you can see that the return speed is high, the second gear. So, if the distances are more than 30 meter, in that case the return speed will be still more. The return speed will be for the empty bucket, it will be 80% of maximum speed in the second gear. Okay. Hope you remember when the distances are less than 30 meter, the return speed was only 60% of maximum in the second gear, but for distances greater than 30 meter, the return speed will be 80% of maximum in the second gear. It is greater for the greater haul distance. Okay. So, the total cycle time, we have to add the fixed time plus your onward journey time as well as the return time. Now, how to estimate the production? Okay. So, the production estimation is going to be similar for most of the machines. Okay. So, you know the heaped bucket capacity for the particular bucket given by the manufacturer. That bucket capacity you are going to adjust with the help of the bucket fill factor. So, the bucket fill factor will depend upon the material type which you are going to handle at your project site and the mounting of your machine, whether it is wheel mounted or crawler mounted. Depending upon that, you have to apply the bucket fill factor, and that value is also available from the literature. Then divide it by the total cycle time. It is nothing but your fixed time plus variable time. If the travel distance is negligible, you can take the fixed time itself as the total cycle time, that you can directly take it from the manufacturer, and you have to multiply by the job efficiency, like how much time the machine is working in a hour. So, with this you can get your the productivity value for the front end loader. So, there are different ways to estimate the productivity. Sometimes the equipment manufacturer may also give you directly the productivity value, okay, with respect to the haul distance and for different bucket capacities. Okay. So, these are just some sample curves to show you the trend. Okay. So, you can see that these kind of curves are also available in the equipment handbook provided by the manufacturer. From there you can directly choose the productivity value depending upon the haul distance and the bucket capacity. Okay. So, then you have to adjust that value according to the your project conditions. Now, let us work out a problem, okay, and see how to estimate the productivity of the loader. Okay. So, estimate the hourly production in kg of a wheel loader with a bucket capacity of 2.87 meter cube. Okay. The rated bucket capacity is given 2.87 meter cube. It is a wheel mounted loader. Job efficiency is given as 45 minutes per hour. This loader will be used to load the truck from a quarry stockpile of aggregate with maximum size of 19 mm. Okay. So, the loader is going to load your truck, okay. So, from a stockpile of aggregate, okay. The aggregate size is also given because depending upon your size, the filling ability of the material will vary, the bucket fill factor will vary. So, that is why even the size of the aggregate is given. Bucket fill factor will depend upon the size of aggregate. Okay. So, from the literature you are supposed to choose the bucket fill factor. For this problem it is given to you directly as 85%. The aggregate has a unit weight, loose unit weight of 1660 kg per meter cube. So, this will help you in the weight estimation. The trucks are placed very close to the loader and hence the haul distance will be negligible. Okay, it is a very ideal condition, like the truck is placed very close, so the travel distance is negligible. Okay, so you can directly take the fixed cycle time from the manufacturer, and the fixed cycle time is given to you in this problem as 30 seconds. Okay, so that will include your time for loading, dumping, turning, changing the gears. Okay, so mostly it will work in the reverse gear, as I told you the ideal setup. Okay, so the minimum travel involved, the time for the minimum travel involved, okay, for that minimum distance is given directly by the manufacturer, and here it is found to be 30 seconds. So, let me summarize the input data. Size of the bucket 2.87 meter cube, bucket fill factor is 85%, and the loose unit weight is 1660 kg per meter cube, and fixed cycle time of loader is 30 seconds. Now, let us work out the solution. The first step will be you have to do the checking for tipping. So, particularly for the front end loader, as there are more chances for the machine to tip forward, okay, if you are going to overload the bucket. Okay. So, that is why we have to check for tipping. Okay. So, we have to make sure that the weight of the load in the bucket is going to be well within the full turn static tipping load defined by the manufacturer. Okay, that should be the first step. Okay. Now, let me estimate the load volume. Okay. So, the bucket volume as rated by the manufacturer is 2.87, okay, multiplied by the bucket fill factor 85%. So, that will give me the actual bucket volume, actual load volume in the bucket as 2.44, okay, loose meter cube. So, you got the bucket volume as 2.44 loose meter cube. This bucket fill factor is based upon the material type. Here we are handling aggregates, and aggregate size is given as 19 mm. So, depending upon that, bucket fill factor is 85%, and also depending upon the mounting. Here it is wheel loader. So, corresponding bucket fill factor is 85%, and the actual bucket load volume is 2.44 loose meter cube. Now, let me find the weight of the material in the bucket. So, for that I should use the unit weight of the material as given in the question as 1660 kg per meter cube. Okay. So, multiply this by the unit weight of the material. Okay. You will get the weight of the material in the bucket in kg. Okay. 2.44 multiplied by 1660. Okay. 2.44 multiplied by 1660 gives you 4050.4 kg. So, this is the weight of the material in the bucket. Okay. Now, let me check for the tipping. For that, I need to know what is the full turn static tipping load for this bucket capacity. Okay. That is given by the manufacturer as 9525.44 kg. Okay. Fine. So, as per the guidelines, the permitted operating load for a wheel loader is your load in the bucket should be within 50% of the full turn static tipping load. Okay. So, let me find what is the permitted operating load. 50% static tipping load at the full turn is 0.5 into 9525.44, okay, 9525.44, okay, into 0.5 gives you 4762.72 kg. So, this is the permitted load. Now, let me check what is the actual weight of the load in my bucket. Actual weight of load in my bucket is 4050.4 kg. Okay. So, this is very much less, this is less than the permitted load. Permitted operating load is 4762.72 kg. Since this is less than this, the machine is going to be stable. Okay. Suppose if your material is going to be greater, the weight is going to be more than the permitted operating load. In that case, this will be the limiting value. Okay. So, you cannot go beyond that. Okay. So, that you have to take it as a guideline. So, you have to load the bucket only to this. Okay. Now, let us see how to estimate the productivity of the loader. Okay. So, you know the volume of the bucket. Okay, so volume of bucket is 2.87 meter cube. Okay, so you adjust it with the bucket fill factor, which is nothing but 0.85. Okay, so you know the cycle time. The cycle time is nothing but 30 seconds. So here they have asked you to estimate the productivity in kg per hour. Okay, so they have asked you to estimate the productivity in kg per hour. So let me convert this seconds into hour. Okay, 30 seconds divided by 3600. Okay, the job efficiency is nothing but it is working for 45 minutes in an hour. So 45 divided by 60. So as you need the productivity in kg per hour, you have to multiply the volume by the unit weight of the material. So the unit weight of the material is given as 1660 kg per meter cube. Okay, so if you simplify this, you will get the production as 3,64,461.3 kg per hour. So this is the probable production of this loader. Okay, so this is how you have to estimate the productivity of the loader. So let me summarize now. So we have come to the end of this lecture. So we have discussed about the different types of loaders and their attachments and the corresponding applications, and we discussed the significance of the bucket fill factor. Okay, depending upon the material type which you are handling at the site, the filling ability will vary for the material. Okay, so not only it will vary with material type, it will also vary with respect to mounting. So accordingly, you have to adjust the rated heat capacity of the bucket given by the manufacturer with the bucket fill factor. Then another important thing, particularly for the front end loader, we have to check for the tipping. We have to check whether the weight of the material within the bucket is well within the full turn static tipping load for that machine as given by the manufacturer. Okay, so the factor of safety is also given in the literature. So depending upon the mounting, you have to check that. Okay, then we have seen how to estimate the productivity of the loader. We have wrote an illustration. So these are the textbooks which I have referred for this lecture preparation. You can go through that. So in the next lecture, we will be discussing about the other types of excavators, let's say front shovel and the backhoe, which are fixed position excavators. Okay, as I told you, the fixed position excavators are have very poor mobility. Okay, so they are not designed for travel from loading to dumping position. Okay, so they will just swing the boom from loading to dumping. Okay, so we will be discussing about those fixed position excavators in the next lecture. Thank you.